Okay, we are recording.
Yeah,
So, cliched question से ही start करेंगे obviously, which I let you know, which is Hardik. Could you go ahead and introduce yourself as a start?
yeah, sure. So, guys, myself Hardik, and I'm an electrical electronics engineer. So, currently, I am working as an embedded engineer in Ahmedabad. So, here I am responsible for making new products. So, I design PCBs and write firmware for them. And in my free time, I enjoy making DIY and tear down videos on YouTube. So, I'm into electronics and I just want to make stuff. So I guess that's all about me.
That was good enough, I would say, in the sense uh, that I didn't know how to introduce you apart from, hey, I know Hardik, he does
Yeah,
PCB.
yeah.
But chalo, now that we have you, we'll go in the direction of
Mm.
go back and talk to us about your college years and how you actually got interested in PCB design. I mean, that's how I know you,
Okay.
PCB person. But if there is another backstory, then enlighten us on that.
So the thing is, मतलब मुझे बचपन से मतलब आई एम इनटू इलेक्ट्रॉनिक्स एंड initially in my initial days जब my father just give me something and I just when my mom जब मेरी मम्मी सोने चली जाती थी दोपहर में so I
Mm-hmm.
just open them and
Mm-hmm.
so I got an interesting part that DC motor. So I'm very
Okay.
passionate about that.
Okay.
So वो
Nice.
मतलब मुझे बहुत ज़्यादा ऐसे मज़ा आता था कि
Hmm.
भाई मतलब ये तो बढ़िया चीज़ है
Hmm.
and so so I'm interested in electronics from there. So after that, in class 9, I got to know about Arduino.
Nice. Okay.
Yeah. So पापा से बोल के फिर वो ऑर्डर कर लिया. So
ठीक है.
so then make some bunch of projects on Arduino and making stuff. Initially काफ़ी ज़्यादा मतलब पागल भी बने. So
Okay.
yeah. So YouTube पे वो वीडियोस आती थी कि you can make your earphone wireless just by wrapping aluminum foil on it. So
Okay.
I tried those
And
and
did it work?
no, obviously
Okay.
that's not wireless technology works. So ऐसे करके मैंने आई गेस अराउंड 3-4 तो मैंने खराब किए हैं आउट ऑफ
Hmm.
क्यूरियोसिटी.
Hmm. Hmm.
So I did these type of electronics project and doing watching how to videos on internet
Hmm.
just to learn stuff and sometimes कभी कभी मतलब ऐसे ही एक यूट्यूबर था जेरी रिक एवरीथिंग.
Ah,
So
yes. I think
yeah,
he's still around. He,
yeah. He is
scratches
still
and breaks the
around.
iPhones.
Yeah,
Okay.
स्क्रैचिंग आईफोन्स तो सो उसको देख के मतलब बहुत ज़्यादा ऐसे इंस्पिरेशन मिली. सो
Nice.
आई ट्राई टू ओपन माय फोन एंड आई
Ouch. Okay.
एक्सीडेंटली या. सो ऑल दिस इज हैपनिंग व्हेन माय जब जब भी मम्मी मतलब सोने जाती हैं तब मैं आराम से बैठ के ये
Right.
सब कर रहा होता हूँ.
Right.
और
Right.
फिर मैं चीज़ें छुपा देता था किसी को पता नहीं चले.
Under the rug stuff, na? ठीक है.
या
Correct.
तो
And remind me again, you're telling this was ninth class ish
यस.
when you got introduced to Arduino. Uh,
या.
and also then maybe put the year on it. Like which year was it? How far back in past?
सो ये जो फ़ोन वाली स्टोरी है ये तो आई गेस अराउंड 9th क्लास के भी पहले की है.
True,
सो
but which year? Like 2000 what?
ऐसे तो याद नहीं है मुझे बट
Okay. Never mind. Never mind. Okay. Okay. But then you started to play with Arduino, got interested in
yeah,
tearing
before
down tech.
Arduino, the thing is, I landed on Arduino because I want to make something, and that I want to make a taser which acts on a certain uh,
Hmm.
action is triggered. So
Nice.
so all those functions you can make very easily in Arduino. So
Right.
so then I introduced to Arduino. Otherwise, before this, I am making stuff electronic stuff like
Mm-hmm.
making initially जब मैं छोटा था मतलब uh, there is a rechargeable torch वो बहुत ज़्यादा
Right.
बिकती थी.
Right.
सो सो अब ये उस टाइम पे मुझे तो ये आता नहीं था. सो
Mm-hmm.
बट मैं जब बचपन में मैं मोमोज खाने जाता था उसके यहाँ पे होती थी तो उसने बनाई थी.
Okay. Okay. Huh.
So I learned from that guy how
Okay.
to make rechargeable flashlights.
Nice. And then the battery we are talking about in the rechargeable, this flashlight, was that a
Yeah,
lead acid or was
yeah,
that
yeah. That
the lead acid?
lead acid battery, 4 volt battery, and they are charging with Nokia pin charger.
Oh, wow. The
Yeah,
tiny. Okay. Once upon a time. Yes. Good old days.
and there is no protection circuit, and they just dump 5 volts
Right.
back to the battery.
Right. Man,
And yeah,
going back, I often feel कि बहुत सारी ऐसे चीज थी जिसकी वजह से डैमेज हो सकता था
yeah,
बट हुआ नहीं थैंक गॉड लाइक आई एटलीस्ट नेवर punctured a cell phone battery because had I done that, I think the house would have been on fire.
yeah.
But lucky
I have
you've
done
done
that.
that. Wow.
Yeah,
Okay. How did that go?
yeah. So the thing is, I'm into. I already told I already told you that I like taser stuff and I like this type of making playing with high voltage, although it is not safe. But
Fair.
I did that. So at the time, I guess around 4 5 years ago, I'm making a
Hmm.
taser and it eventually stops working.
And you
So
then touch it because
so the thing is, at that time, I make stuff and wrap it around electrical tape. So all
right
the wires
insulation.
are, yeah. So
Hmm.
all the wires in that electrical tape, and I accidentally uh, cutting that tape, and I accidentally short circuit it, and it blew up
Wow.
uh, like a small rocket, and and there is
Oh,
smoke everywhere.
how did that happen? Okay.
Yeah.
Please guide us on this. Can you paint कि वो कैसे दिखता था? So we are talking about a taser. So
Ac-
taser definitely
I have
has.
another version of it. I can show it to you.
Sure, go ahead.
Just a minute.
Sure, sure.
Let me show it to you. I have around my bag. Let me show it.
When you walk around with a taser, okay.
Yeah,
सबकी अपनी अपनी हॉबीज और नशे होते हैं. So I think this is yours. Wow. Okay.
yeah. So this is the version 3. Uh, it is visible in the camera.
You literally have a taser with you,
Yeah. So
and the pins are pointy. Maybe put your hand like, oh god, that is quite okay.
yeah.
Okay.
So this is the version 3 of the
Fine.
same item. And so I blew up version 1. So this is the third version. This is the third version, and I can start it. So here we have two switches. The first one is here, and
Safety
another
switch.
is the push button.
Fine. Okay.
So
Oh god. Wow.
it is working.
That that's so cool.
Yeah. And
Okay, so
and
turn it
in
off.
this
Turn
I
it
have
off,
used, yeah,
please.
in this I have used Lenovo battery. uh, I accidentally tear down that a phone, तो वही रीयूज कर लिया था लिथियम आयन. वो 4000 mAh का बैटरी था.
Man, this is so
and
cool.
and this is rechargeable also. You can charge it.
Understood.
Yeah.
What do you use this taser for?
uh, so just lying
Nothing.
around my bag and trying to एयरपोर्ट पे एक्सप्लेन करना पड़ता है कि क्या है ये, क्यों है ये.
You have traveled with that on the
Yeah,
plane,
yeah,
and this is beyond. This is so fun.
yeah,
This is so fun. Wow. Okay, so you made version. This all of a sudden became so fun. So
yeah.
version one of the taser. How did you blow it up? Like short circuit it, and so the battery or the capacitor overheats and explodes, something of that nature. What happened?
Yeah, so most probably I think is, uh, so there are two wires going on around the charging cable. So
Correct.
back then I'm not using TP4056 charging IC. I'm just giving directly voltage to the battery. So there is no protection. So if you short circuit something, and it will blow up.
Ah, so it being what? The solution or the wall socket and the charger?
So the charger.
What? The charger blows up. Okay, perfect. And
No,
you,
the battery blows up because charger doesn't know about battery that much.
I see, I see. So it's not limiting its current or in it just
Yeah,
okay, overcharge protection
accident,
is not there.
yeah, and you accidentally touch the positive and negative of the battery terminals, and it just blows up.
So you have had that happen. Very
Yeah,
nice. I'm not recommending anyone do this, by the way.
yeah, yeah,
Fair,
yeah. Please,
not recommended at all. In fact, in
unsafe.
fact, we are just talking. We are not recommending anything to anybody.
Yeah,
Wow. Okay. So that blows up. Fine.
yeah.
I'm still curious. You go around with the taser. That is so. I don't know what to call it. Is it
Actually,
awesome? Maybe.
I have many electronics stuff in my bag. I also carry a 36 in 1 MI screwdriver kit.
That I can understand.
Yeah,
Fine. Somebody somewhere might need it.
yeah,
Taser. Oh, you could. Okay, I could speak in your favor. I mean, speak in favor of carrying the taser around, which is
yeah.
capata. You might need to jumpstart somebody's car. I don't know, car, vehicle, some sort of something.
I guess
Safety wise, like I don't think you need that. Okay, it's like okay, step one, turn it on, boom, done. Step two, tak I don't think. Wow, wow.
I,
Okay,
actually
you're
things become very interesting if अगर आप इसके आगे एक deodorant और लगाएं which I am not
ooh
so
again not recommended at all.
yeah, so but it
Wow,
is fun stuff.
fun stuff. Yeah, pure fun stuff. Wow, like literally wow. I'm not able to go past that. So okay. Let me still move the. You were talking about Arduino, high voltage stuff. Taser
Yeah,
is something you clearly like. Like I'm convinced.
yeah.
How did you go from? Okay, talk to us about then Arduino. How did you use it in a taser? How do you generate high voltage? I mean,
So
I should know this.
yeah,
For my viewers, also electrical engineers, so Cockcroft Walton circuits should be involved somewhere. But like a capacitor and I think uh, diode ladder, something of that nature.
yeah.
But go ahead. How did you create the taser?
So initially, I watched a video on. So I guess there's a YouTuber named as Hex Smith or something like that.
Okay.
So I watched his tutorial how to make tasers.
Okay.
Yeah.
Okay.
So I learn all this from his tutorial, and
Okay.
then after that, I thought let's make instead of pressing a physical button, what if I make a touch button? Okay.
Right.
At
Yep.
that time, I watched
Absolutely.
Iron Man, so
Of
I thought
course.
let's automate it. Let's make something called something uh, some taser, combine taser plus glow, some gloves. So
Nice.
yeah,
So you literally have like taser on your hand. Like nice, nice. Okay, so touch control tasers. And did you zap yourself? Did that happen?
uh,
Did you many
once or
times?
twice,
Once or
once or
twice.
twice.
Okay. Wow. Wow. Okay. You did electronics.
Sorry.
You did electronics engineering.
Yeah, I did
Okay.
electronics engineering,
Okay. I
and
think. I think.
yeah.
Go ahead. Go ahead.
So I don't know why I like this stuff, making things worse. So in my college days, why I don't know why I did such things. I just blew up capacitors for no reasons. Just connecting
Okay.
just directly. So maybe this is the inspiration from, there is a guy on YouTube named as Electro Boom.
Oh
So,
yes, of course. I love him. I love
so
him. Yeah.
yeah, so maybe I got inspired from him.
But he does put a disclaimer saying to not.
Yeah, तो
Wow.
मुझे मतलब बहुत मजा आता है वो सब करने में, although it is
Very
not
nice.
safe.
I mean,
Yeah,
fair. You're taking your own risks, but maybe now you take well, more informed risks. Like you're
yeah,
aware of what can.
yeah.
Wow, wow. I have to mention this. I did not work with the lead acid battery until my final year of college because
Oh,
I felt I do not understand that battery completely.
okay.
I just felt that at some point something can go bad and the acid will leak or something will happen, and I'm not ready for that.
Yeah,
Like
actually,
I've done other shit, but this is
this is the
man,
same.
this is
This is
pure
the same
gold.
story. There is a story in my school. तो
Hmm.
एक बार स्कूल में बैग चेक हुआ,
Okay,
and they found a lead acid battery in my bag.
okay, this is drugs equivalent in
Yeah,
the school.
but for for a class 7th, 8th student, it is just a hobby project, and
Fair.
it is just like a toy.
Hmm.
So उस समय मुझे इतना पता नहीं था कि इतना कुछ होता है,
This
सो
can, yeah, exactly.
लेड एसिड बैटरी।
Hmm.
तो सो बैग चेक हुआ, तो सब लोग उस समय फोन लाते थे या कोई कुछ, तो आई थॉट कि इसको छुपाने की क्या जरूरत है, दिस इज वेरी
Right.
कैजुअल स्टफ, एंड आई एम नॉट smoking or something. So,
Yep.
but at that day, they called my parents because of this.
Man, this is wow, fun stuff. You
Yeah,
you are into some real dangerous stuff. I mean, it
yeah,
becomes dangerous from the standpoint. Well, you weren't rather aware of like the downsides or the dangerous side of things.
yeah.
Hope
To be honest, at that time, I'm not. I, I just liked stuff. I
exactly
didn't,
like
I didn't think about the risk part.
precisely. It's like here's TNT. I like TNT. I'll put it in. That's how it feels like. But kudos to you as a kid,
Yeah,
because somehow your curiosity got such dangerous stuff out of you. But okay, then guide us on. So Ordino, because well, you wanted to create a taser glove.
yeah,
Okay, and then you were also into blowing up capacitors, which is something
yeah,
I deeply appreciate. Because okay, unrelated to capacitors but equivalent.
yeah,
So the reason I asked you if you are an electronics engineer
yeah,
is because in electrical engineering curriculum final year we had this subject of high voltage transmission
yeah,
and things like that.
yeah,
And I believe the electronics guys don't have high voltage subjects. They steer towards low voltage RF and things like that, right?
yeah.
Towards like the third and fourth year. So we
Hmm.
had this high voltage lab experiments where
Yeah,
we would have like a proper, Tesla coil set up in a cage and all of that. And obviously we were to never enter that cage because well, you can die
yeah,
if things go wrong.
yeah,
So adult supervision was always there. The teachers, it was in a Faraday cage, so no problem. But the experiments were all relating to blowing up things. So, and the reason I asked you all of that was, somewhere I felt that you would have enjoyed that the most. But turns out you have done your own, explosive stuff. Okay,
yeah,
the things we were into in terms of, let's say, exploding was we had to check the breaking point of different, let's say, materials. So
yeah,
what can be a good insulator? Well, you just check it by raising the voltage across
yeah,
like a cube or so, and then at some point you hear
yeah,
this, you know, explosion equivalent where either the material is gone or,
yeah,
well, it's broken and all of that. But it's fun. It's destructive and it's fun.
Yeah.
So, okay, I could relate to that. I've never explored capacitors. I don't know why. If it was like rated 25 volts, I would always be at 5 volts. No reason to go to 25.
Maybe you should try one.
I will. I definitely will. Diwali is here, so why not? But
Yeah.
okay, but what should I be mindful of? And all of a sudden, this is turning into okay. Let's blow things up.
Yeah.
But okay, talking about capacitors, what have you learned about them? Like, how do they explode? What should I be careful about?
So the important lessons I learned there is, so whenever you design a PCB, always make sure that you let's if you making uh, if you're making a PCB for 5 volt architecture,
Mhm.
always use some 12 to 15 volt capacitors. Otherwise, they will blow up like this.
Why so?
Because the thing is, if you don't put this is the general convention. If you don't
Okay.
put अगर आप ज़्यादा वोल्टेज का नहीं लगाओगे, so generally what happen is,
Mm.
after some times on these capacitor plates they get wear and tear down, and there is a voltage rating,
Uh
specified
huh.
voltage rating. So
Okay.
if you don't follow that, they will blow up.
Damn. Okay. Okay.
Yeah.
Now I understand why. So back in 2007,
Yeah.
uh, there was like a thunderstorm. Somewhere there was a lightning strike,
Yeah.
and as a result of that, our TV, the CRT
Yeah.
TV,
Hmm.
that stopped working. And that was at least my uh,
Yeah.
exposure to electronics. So this technician comes in, he opens up the TV, and I just see like green color board with transformers and big capacitors and all of that. Ever since then, I'm
Yeah.
wondering why the capacitors have a value, at least on that board, of like 250 volts,
Yeah.
500 volts, and all of that. Well, now I
So
understand.
this is a similar concept. So the thing is, Taser is also using the same concept. So
Yes,
we pass a high voltage from these electrodes.
yes,
So air get ionized,
yes,
and it starts conducting.
yes.
So similarly with voltage. So similarly with capacitors. So if 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 we see from capacitors point of view, so there is two plates, and
Oh, I
yeah,
see. I understand. So you're saying
yeah,
that the charge builds up so much so that
yeah,
the insulator in between breaks, and
yeah.
the
So
moment that breaks, you've
yeah,
lost the capacitor. Go ahead, explain.
yes. So that's what I'm telling. There is a dielectric material between both plates.
Yes,
So if we pass a high voltage between them, so so that dielectric material has some strength.
yes.
अगर voltage ज़्यादा होगा, so it
तो फट
electron
जाएगा वो.
gets, yeah, jump from one plate to another
Plate
plate.
to another, right?
Yeah,
You effectively have a short. By the way, that is precisely what the high voltage lab was for.
yeah,
Except the materials being tested where you could
yeah.
you could argue they were dielectric. So, but then can a 5 volt capacitor break on 6 volts? Is it that fragile?
Uh, Sometimes it works, but the thing is, uh, with these capacitors that you are using, these capacitors, they also have, uh, like, you have used resistors, right?
Hmm.
So they have some tolerance, right? 5 to
Yes,
10% tolerance.
I see
Okay.
what you mean.
If
Yeah,
some capacitor is 10 mu f and 5 volts, तो वो
right.
एग्जैक्ट वोल्ट का नहीं होता है, तो चलने को चल सकता है, बट इट इज नॉट रिकमेंडेड.
True, true, true. It might so happen you 4 volts पे ही damage हो जाए.
Yeah, but
Right.
generally
Okay.
it's a convention that if you are making stuff, तो अगर कोई चीज 5 वोल्ट की है, तो that you should use 15 volt or some 10 volt at least. Twice is,
Twice is recommended. Fair,
yeah,
fair. अच्छा, well, I was interested in the fact that ऐसा कुछ होता है क्या wherein there is like voltage multiplication happening. Just if
yeah,
I'll give you an example. So in case of inductors or motors, for example, the
yeah,
moment you take power away from them,
hmm,
they have the tendency to generate like a back EMF,
yeah,
right? So I was wondering if with capacitors something like that happens, which leads to like a damage. There is like an inductor somewhere
Yeah,
in between the switching. For some reason, the power is taken, and then it induces like a voltage surge, and that goes to the capacitor, and
yeah.
capacitors out.
So the thing is, there are different type of capacitors.
Okay.
So the some are polarized capacitors. So generally,
Hmm.
we see some cylindrical capacitors. So
Yes.
those have clearly markings that you should put this terminal on positive side and this terminal
Right.
on negative side.
Right.
So if you reverse the polarity in that capacitor, it will
Hmm.
get blue.
Very easy to do that. Okay.
Yeah.
Fair.
So and
I'll
there are
start there. And there are non-polarized or unpolarized.
yeah. So there
Go
are
ahead. I
some
mean.
yeah, there
Hmm.
are some capacitors
Hmm.
uh, which are which can tolerate reverse polarity. Like we have some ceramic capacitors.
Hmm. Hmm.
उसमें ऐसी कोई दिक्कत नहीं होती है.
Right. So
Yeah,
they are the ones with actual two plates.
yeah,
The
yeah.
other capacitor is like two plates, but
The
the plates
basic concept is two plates. Actually में जब
separate
हम
charge.
या एक्चुअली में जब हम देखेंगे तो सिलेंड्रिकल वाले भी जो हैं, सो उसमें वो दो मेटेलिक फिल्म को ट्विस्ट करके डालते हैं.
Right, right, right.
या
Well, what I was getting to was a capacitor, obviously, two plates or two surfaces very close to each other. The goal being separate the charges or let.
या एंड मिड में डाइलेक्ट्रिक मटेरियल.
Correct, correct. And as you rightly mentioned, in case of cylindrical, it will be like a paper in between two
या या
sheets that is like four.
या
Fine. So what I was wanting to point out was that maybe one, like the electrode or the one side plate, the positive plate, let's say, is built out of another material, and the negative one is built out of another material. That gives you like the most charge separation. But once you invert the polarity, something bad happens. They break down or something like that. I was just trying to reason ki polarity would mean what in a capacitor. Like how would you physically go about
या
implementing a capacitor?
दैट्स अ गुड क्वेश्चन. आई नीड टू गूगल इट
Yeah,
दैट
man.
मटेरियल इज सेम और डिफरेंट. टू बी
I'm
ऑनेस्ट,
I'm
I didn't think about that.
I'm guessing it should be different from the standpoint that it was expecting ki you will put like, let's say, positive terminal to it, but instead you put negative, and maybe you sucked out some, I don't know,
Yeah,
whatever, reverse flow happened, some batch stuff
yeah,
happened, and it went into like a runaway of some kind. And
yeah.
well, never mind, this is the limit of my knowledge on that. Guesswork on that.
That's a good question. I need to check.
We'll I'll check also.
Yeah,
Cool. So wow, okay. So tasers, capacitors, blowing them up, college years, again, blowing up capacitors. So talk to me about how did you get into PCB design? How did that happen?
yeah. So in my final year,
Hmm.
I decided to make a electric bike.
Nice.
Yeah.
Go ahead.
So initially, uh, we have teamed up 5 people,
Hmm.
and I don't know why दो लोगों ने छोड़ दिया. उन्होंने कहा कि
Nice.
कॉम्प्लेक्स सही है. I think we should pick something simple.
Yes.
So उन लोगों ने छोड़ा तो मुझे बहुत ज़्यादा ऐसे आ गया कि that we should make this.
Yeah, we should make this happen so that they
Yeah,
regret.
yeah.
Okay.
So उसके लिए हम जब कंट्रोलर बना रहे थे, so we have tried to make our own controller to control that BLDC motor. So
Wow. Okay.
yeah, so I
Wow.
got inspired from a YouTuber name as Great Scott. Very good video.
Yes.
Yeah,
Yes.
उसके वीडियोस मैं अभी भी देखता हूँ कुछ भी नया.
Yes.
So
Great Scott. Yes, I've watched a lot of his videos. Correct.
so
Hmm.
उनका एक वीडियो था making e-bike controller. So I thought let's make a PCB of it.
Okay.
या सो वहाँ से मुझे पीसीबी डिज़ाइनिंग के बारे में मालूम चला और फिर उसमें मुझे इजी ईडीए पे एक बंदा
Hmm.
था उसने
Hmm.
बताया। तो फिर हमने इजी ईडीए पे वो बनाया था, एंड पीसीबी बन गई, एंड इवेंचुअली इट विल फेल। हमारे मॉसफेट्स उड़ रहे थे। सो
Man, your MOSFETs were blowing up now.
yeah, नहीं, अब now the thing is, here it is not intentioned.
And I understand, like it's
Yeah.
I don't know, explosive territory. So, which then tells me that again something related to ratings is going wrong with the MOSFETs. What was happening?
I guess that there is a method we need to, uh, मतलब कोई भी मॉसफेट है उसको एक उसका RDSN ऑन और वो सारे मेथड्स होते हैं, वो
Okay,
हमें वो हमें पहले चेक करना होता है। सो आई जस्ट कॉपी द एग्जैक्ट स्कीमेटिक फ्रॉम द रिकमेंडेड गाइड। सो
nice.
एट दैट टाइम I don't know what I am dealing with, so I just copy paste stuff, and without understanding what's my constraint and what's the load of my motor. So
Hmm.
I so the major fallback in that design is the motor the YouTuber is using is
And the
of
one you are
15 ampere, 15 to 20 ampere, and
okay.
the motor I am using is around 30 ampere.
I see a problem right there. So your MOSFETs were carrying a lot more current
Yeah.
or than intended, which then
And,
means they were heating up a lot
and
more.
apart of that, there is exact turn on mechanism and turn off mechanism for MOSFETs. So generally we have to study them, which I don't.
Yep.
Yeah,
You are like, watch this. It's
yeah.
going to work
So
smooth.
at that time, I just curious and I make stuff. So I didn't think much about it. It will work or not. So after that, when it not work, then I understand like, oh, I forget this. I should have thought about this.
Right. Man, this is so fun. So your how far did the electric bike project go? Did
Yeah,
you manage to turn the wheel? What happened?
my actually with my controller we further मतलब हमने छोड़ दिया कि वो बनने वाला है।
Okay.
ठीक है, बिकॉज ऑफ द डेडलाइंस हमें सबमिट भी करना था प्रोजेक्ट।
Fair.
सो वी यूज ऑफ द शेल्फ कंट्रोलर,
I
एंड वी
see.
डिजाइन अवर ओन बैटरी पैक देन।
Fair, which is
या
and the battery pack you designed that had like what LFP batteries or
या
NMC?
LiFePO4।
Fair. Okay. So those are I suppose non-explosive. Yeah.
एक्चुअली दोज आर आल्सो एक्सप्लोसिव, बट
Sorry, what was it? Li lithium.
LiFePO4 आयरन फॉस्फेट।
So I think the iron phosphates don't explode. They don't burn also.
Yeah, actually, it is much safer comparative
Yes.
to lithium ion and lithium
Lithium
poly.
ion explodes. That just
Yeah,
push.
comparatively less explosive.
Huh. Have you exploded that?
No, 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 no.
No, okay. We're not there yet. Okay,
Yeah,
fine. Fine, fine. Well, interestingly, I had been to Hyderabad like two, three, well, first week of September.
yeah,
And there is a very famous place there, Gujarati Gully, which you get like electronic components and all of that. And as a kid, like eighth class, I used eighth, ninth, tenth, I used to go there, obviously with my father, and then shop for LEDs and things like that. So this
okay,
time around, when I went there, they had batteries, and I had no idea what I would do with the batteries, but I got the
yeah,
lithium phosphate ones, and I
okay,
got them only because I understand they are way safer than the NMC batteries. Definitely
okay.
better than NMCs. But okay, we haven't exploded lithium iron phosphate yet, so
Yeah,
I think it's unlikely. By the way, so the car I have that has got LFP batteries,
okay.
and LFP batteries have passed like nail penetration test and all of that.
Yeah,
But now, what I understand is it might have to do with the way the cells get, like the cells are structured and arranged,
yeah,
rather than the chemistry itself.
yeah,
By the way, on that note, I'm also happy that you're not into chemistry with the same enthusiasm. It's like, let's see what this does. Okay, good, good. I mean, I'm not saying that you should never try chemistry. It's just that it's just the experiments I believe would have been more catastrophic.
Yeah,
Cool. Wow. Okay. So then you tried the bike. The
yeah,
bike project was like, I can imagine how that started. It's a grandiose goal. Then
yeah,
tune it down. Two people are out. Tune it down further. Bad stuff happens. Down to off the shelf stuff. Make
yeah,
and when you made the battery pack, did
yeah,
you like do the contact welding of the battery
yeah,
terminals?
yeah. So we purchase a welder
Nice.
from some random website
Very nice.
which didn't work.
How did you weld it?
तो हम किसी एक और कॉलेज में मशीन थी तो हम वहाँ पे गए थे,
Fair.
तो वहाँ से वेल्ड करके लाए थे अपने कॉलेज में.
Man,
So
I don't know. The viewers can
aspect
comment.
of electronics is there are many cheap components in which didn't work at all. They are just scams. So
Yes.
yeah, so वो वेल्डर मशीन भी बिल्कुल सेम थी, वो काम तो करती नहीं थी, बट उसका उसका शोकेस और उन लोगों ने मार्केटिंग ऐसे किया था कि ये बहुत बढ़िया है. सो वी
Nice.
थॉट इट इज चीप एंड वी विल बाय दिस.
Yes.
या,
And then you got
इवेंचुअली,
it and it didn't work.
सॉरी,
Sorry, eventually?
इवेंचुअली मतलब हम दूसरे कॉलेज में जाके फिर वो हमने वहाँ पे कर
Fair,
लिया
fair.
था.
Right,
या,
right. So you had to get it from another institute. Cool. So you are now past your final year. Did you have any PCB at any point functional?
इन कॉलेज नो.
Okay. Okay, fair. I feel nice because, well, same story. I didn't have any PCB working. I
आई हैव
think,
आई हैव ट्राइड 2 3,
hmm,
but but it didn't work, and some of them I, मतलब मैंने मैन्युफैक्चरिंग के लिए ही नहीं दी. I just designed them and
okay.
yeah,
Oh, so I suppose, which year was this?
I guess it's around 2023.
2023. So like 2 to 3 years
2020,
back.
या मतलब मैं 2023 पास आउट हूँ, तो ये तब की बात है
Okay,
कि
fair.
एट दैट टाइम आई एम इनटू पीसीबी डिजाइनिंग. तो वहाँ पे मैंने मतलब कुछ जैसे ESP32 का ट्यूटोरियल देख लिया तो उसका बना लिया.
Hmm.
So I'm not into manufacturing stuff. I just make stuff.
Right, right.
Just
And we'll come to the manufacturing part in a bit.
yeah,
But okay, I was going to quote that my experiments with making PCBs date back to 2008, 2011 time frame. And
yeah,
I had no idea of how to send the Gerber file to some fab. And also, by the way, a brokey completely. So had no cash, never.
yeah.
So we had this option of ferric chloride and developing the PCB, on our own.
Okay,
And what I used to do was, so I had this book, 71 projects, electronic projects in one. And that book had like a project and the PCB associated with it,
okay,
the stencil of the PCB, so to speak. So I would then draw things with a marker, like hand draw it, then
okay.
take electrical tape,
Yeah,
cut uh, parts of that tape and then use them as tracks, then
yeah,
dip it in the ferric chloride and then, steer it so the copper dissolves, unexposed copper dissolves. And after that, whatever was left, poke holes in it, put ICs through, and then solder. None of them worked.
that is very
None of
hectic process. That
it
that
is
is
it is very hectic. And by the way, back then the projects we, like, let's say my peers and I were into, were
yeah.
mostly IC based.
Okay.
Arduino had just come out back then, and those who
Yeah.
tried Arduino, like, man, they would go crazy. It's like, oh man, I can't believe, just write like 5 lines of code. And
This much simplicity.
yes, and me and bunch of my friends, we were, well, electrical, right? So We were
Yeah.
far away from the software world. What an irony, though. I do software now, but back then that was the case. And me and my other friend, and I must interview him also someday. So we were into, okay, let's make a PCB from scratch, and then our method was not KiCad or Eagle, none of that. It was like, okay, tape. None of them worked. None of them worked.
Yeah.
Wow. Okay. So 2023, you went through all of this.
Hmm.
What happened after that? Oh,
Hmm.
any other projects that you did?
Yeah, so after that I joined a robotics company. So
Okay.
there I design some PCBs based on ESP32.
Okay.
So there I actually learned stuff, and
Okay.
my PC starts working.
Nice. But then you would be, again, do not spill anything that is secret to the company. That's proprietary to them. But I'm assuming that it was like a team of people that you all would, work together, and then brainstorming happens. One teaches the other, and blah, blah. Okay.
Yeah,
Cool. So now let's talk about your YouTube channel. I see that there is, a course that you have put up, which is
yeah.
uh, FT. Sorry, what is that?
You are
FTDI based, yes, UART to
what's
converter. Yeah, would you speak to us about that? How did that happen?
Yeah.
Background.
So that UART स्टेक तो मैं एक पेन ड्राइव यूज कर रहा था
Mm-hmm.
इसकी का सो
Mm-hmm.
तो इट स्टॉप्स वर्किंग
Okay.
या सो मैंने उसको सो जस्ट अ रैंडम थॉट कि
Mm-hmm.
इसको खोल के देखते हैं कि क्या होता है इसमें सो आई
Mm-hmm.
जस्ट टेक इट डाउन and found there is no physical connector on that PCB. So they have just printed USB pads on the PCB itself.
Oh, and that plugs into the USB. Okay, fair, fair.
So I thought this is a good idea and let's experiment with this. What if we make a similar PCB and add
Mm-hmm.
our own circuitry? Like I start with UART that USB to UART converter IC on that.
Mm-hmm.
So that's how I got inspired.
Mm-hmm.
Uh, तो फिर मैं वो बना रहा था. सो आई थॉट कि लेट्स मेक अ सिंप्लीफाइड वीडियो
Mm-hmm.
which is explaining each and every part, how I
Mm-hmm.
import libraries and what is design rule check, what is board setup, and all those while making stuff.
Right.
Yeah. So that's how I start that.
Nice. And well, it works.
Yeah, it works. It
Nice.
works.
But the reason I asked that is, if we just look back at your journey now,
Yeah,
it started off with, curiosity, randomly trying things out,
yeah,
lead acid battery, motors, and whatnot. Then somewhere there was like, hey, tasers. And then
yeah,
after that, there is, electric vehicle of some sort, like a two-wheeler, right?
yeah.
And then,
Yeah, we convert that Activa into electric one. So there is a
wait,
channel. Yeah.
what?
So there is video of all this conversion happening on
Wow.
my channel. I will
Wow.
share the
Nice.
link.
Nice.
Yeah.
We'll put those in the description.
Yeah.
So, oh wow, man, this is so good, so inspirational also. So you took an Activa, took a wheel out, pretty
Yeah.
much, then put the BLDC. The engine's completely cut off now, so
Yeah.
no, petrol engine related stuff.
Yes. Yes.
Where was the battery in the dicky?
Yeah. Yeah. We cut it out.
Nice, nice, not too far away from what I imagined. Okay, and then there must be like two set of wires that come to the throttle,
Yeah.
and then okay, fair. So I'm able to imagine it. So you now have like a two-wheeler thingy going for you with the board design still failing.
Yeah.
Then you are out of college, and then you're working at a company where again you are into PCB design.
Yeah.
So what the fact that you had designed PCB in the past helped you to make a
Sorry.
case for the fact, like, I'm now talking about you getting that job, right?
Yeah.
So the fact that you have designed PCB in the past as a student,
Yeah,
that helped you, or was it something else along with that?
yeah. Actually, we learn from our mistakes.
That is correct, yes.
Yeah.
Few people
So
don't, but the good ones do. Go ahead.
yeah. So generally, there is some minor mistakes or
Hmm.
some fabrication error or generally what happen is we forget to read data sheet, and
Yes.
we thought let's make it instead of let's just copy
Yeah.
the design,
Yeah. Yeah.
and
Yeah.
instead of understanding it, तो
Hmm.
उस वैसे करके बहुत सारी गलतियां हुई हैं।
Hmm.
तो वहां से मुझे समझ में आया कि इसमें ये नहीं करना होता है, and let's do this another time, and
Okay.
there are many senior people which are
Hmm.
which helps me to understand what's the flaws in my design, what are the
Hmm.
flaws in my design, and या और कभी कभी मतलब जब कोई चीज नहीं चल रही है, सो
Hmm.
यू कैन राइट टू सम सीनियर गाय, some YouTuber, or so they
Ooh,
will happy to
nice.
help you out.
Nice.
So there is
Well,
a
so.
channel. Yeah, so there is a channel. I was making something, and it stops working, and initially it works, then it stops working. So I just message him. So there is a guy named as Phil's Lab.
Oh yeah, of course. I've seen his videos too. Go ahead. Hmm.
So मैंने उनको डायरेक्टली मैसेज किया कि सर दिस इज द माय स्कीमेटिक एंड दिस इज माय राउटिंग पार्ट
Hmm.
एंड व्हाट्स द फ्लॉ इन इट।
Hmm.
तो अगर हम पूछते हैं तो फिर बाय चांस उन्होंने बता
Yeah.
दिया।
Right.
सो सो दैट्स हाउ आई लर्न स्टफ।
Nice. You just reach out to people. I think that's how we got connected too.
Yeah, yeah, same,
So,
same.
I should also mention then that at least your PCB design skills is something that we plan to convert in a course for anyone interested. And not only that, well, maybe go ahead and talk about your latest FPGA adventures,
So yeah,
if you'd want to. If you'd want to,
why not?
if it.
So currently we are making a custom FPGA board which is
Mhm.
based on lattice ice 40 FPGA.
Right, right.
Yeah. So so right now it is in prototype stage, and we can share it if
Go
possible.
ahead. I mean, if you'd want to.
Yeah, so this is
Uh,
V2 version.
oh wait, are you sharing your screen?
Yeah.
Well, I can't see it. I should
Uh,
mention this, by the way. We on. Oh, go ahead. Yeah, never mind. Never mind. I thought the podcast can be recorded only for 1 hour, but doesn't look like.
okay.
So, go ahead.
Let me open it. FPGA.
I'll speak in the due time. So, when I and Hardik connected, we just randomly got to talking about, hey, can we design a FPGA board that is cheaper than what's, well, or competitive compared to what's in the market right now, at least for the Indian crowd. Just because at some point, the Pajama Bra team was thinking about doing something on digital hardware. Uh, and yeah, so Hardik has gone ahead and in his free
Yeah.
time designed an FPGA board, which just worked, by the way, in first shot, which
Yeah.
is even more crazy.
My screen is visible.
Yes, just oh wow, okay, we have
Okay.
yeah, it is
So
visible.
here we go. So this is our version one of our board. Let
Man,
me. Okay.
this is it looks beautiful.
Yeah. So this is the back layer, and
Okay.
let yeah. So this is the back side silk screen, and
Mm-hmm.
here is our front layer. So here is our main FPGA board, and this is flash, and here we have PS RAM, and
Mm-hmm.
we
Mm-hmm.
have bunch of headers, to connect some external stuff. Here we
Right.
have reset button,
Mm-hmm.
and here we have USB C.
Damn. Looking at.
Yeah, so this is the main silk screen on front side.
So what does silk screen mean? The fonts and the labels, those kind of things?
Yeah.
Okay.
So this blue text is silk
Mm-hmm.
screen, which helps us to guide, like which pin is this. This is
Ah,
5B
okay.
pin. This is 0A
Understood.
pin. Yeah.
Understood.
So this is the first version,
Mm-hmm.
and luckily it worked on the
First
first
try.
go. Yeah,
See,
everything is.
this is that unsaid part that I was reflecting on, which
Yeah,
is when you mentioned that earlier none of your PCBs worked.
yeah,
Cut to, the first PCB you tried now, like a complex PCB. I mean, this is not easy,
yeah.
right? Uh,
So
and it just worked in like first
yeah.
try.
So right now I'm making this version 2
Mm-hmm.
of the same PCB.
Right,
So here we have bunch of LEDs,
right.
and here we have bunch of switches, and here
Yes.
is our main FPGA board, and some minor tweaks, like here we are
Mm-hmm.
using some smaller switches. So on the first version the switch is very big and we don't need that
Hmm.
big switch. So few design tweaks, and some adding some LEDs and buttons in this. Let me show you uh, in 3D, so you will get some idea. Although it is not completed, I have to route
Mm-hmm.
them.
Oh, I see. So it just
Yeah,
places stuff
yeah,
wherever
I just
it
place
feels.
stuff, and I have to route them.
Right, right, right.
So yeah,
Oh,
guys,
so
all.
there are.
You
Go
are
ahead.
saying something?
No, no, no. You complete your statement. I'm sorry.
Yeah. So that's a version 2. So hopefully I will complete.
No, I think it will be completed and we'll ship it also.
Yeah,
Well, the goal is to make learning learning digital electronics as
yeah,
simple as possible.
yeah,
Maybe what you should do, and I mean what we should do, but you should kind of lead, and I and Mohammed will be like the cheerleader and even the audience.
yeah,
Which is we should revisit back the two-wheeler project and complete it.
yeah.
And
Sure.
I'll tell you why, because somewhere the completion part will help me put some pieces to bed also, which is
Okay.
funny enough. I worked on an EV too. So
Oh, please, please, please.
okay, so I think electrical engineers or those interested in motors and batteries
Yeah,
don't fall off further from each other. So we were I was introduced, well, much like you. So you were
yeah,
interested in like the batteries and things like that. I was very fascinated by capacitors, and
yeah,
that could be like I was very interested in them, and maybe that's one reason that I never blew any one of them, because
okay,
I understood as to what the limits here are.
yeah,
So in my 12th class, I had made an array of capacitors so
okay,
that it can act like a battery bank.
okay.
I somewhere did not understand the concept of energy and power density.
Hmm.
I just like was fascinated by the fact that capacitors can replace batteries. Well, not really, but they can serve that function.
Yeah,
The charge decays like exponentially, so not really a good battery, but
hmm,
nonetheless. And in
hmm.
12th class book on electricity, which has like chapters on electricity, and which reminds me I should go and read them back. But okay, so it has static electricity, electrostatics, all of that. So capacitance as a concept shows up there, and they I remember this distinctly. They had a mention of the fact that a 1 farad capacitor would require plates of the size of Earth, that much huge surface area. That was the claim, something very huge, right? So I have this bank of capacitors, and what I had managed to do by reading those books was
Mm.
create, and which I never understood how it works, never understood back then. Now, no problem. So there was like a oscillator circuit.
Mm.
So the setup was this: you have a capacitor bank, you have an oscillator circuit which hooks into a transformer 12 volt to 240, and on the 240 side I would put a tube light, and the tube light would light up,
Yeah.
right? And that was my, so to speak, moment of pride. So
Mm.
I had taken this, and obviously my 11th 12th class teachers and student peers, and they were fascinated as to genius. But I understood nothing beyond transformers and capacitors. So
Yeah.
then we are at the social, not so, science exhibition.
Yeah.
So I'm from the school in Chandrapur. We have gone to Nagpur, and I was in 11th class then. 12th class is when the concept showed up, and that is where that line was. And I
Mm.
remember that line of the huge plates and all of that, because
Mm.
one of the 12th class guys walked up to me
Mm.
and asked me, hey, how much would it take to make 1 farad? And I'm in 11th class, so I have no idea. We have mechanics,
Mm.
electrostatics, and electronics is yet to come. So I
Yeah.
say, I honestly don't know. And
Mm.
he literally said, hey, dumbass, equivalent of that. Hey, dumbass, it would take like 1 farad. I felt destroyed. I was like, hey, I made something.
Mm.
It's okay if you don't appreciate it. You don't have to. You can just walk by. But you completely take this liberty of walking over my self confidence, treating me like nobody, and then just walking away.
Yeah.
Fast forward to 2 years after that, I was in second year of electrical engineering, and
Okay.
my one of the very senior professors, Professor S.G. Tarnekar, he
Yeah.
had a history of working on supercapacitors,
Okay.
and the capacity of a supercapacitor, and which I have. Oh, let me actually pull one. So,
Yeah.
by the way, polarity. So this one is 500 farads,
Yeah.
right? So that guy told me that you couldn't. It was very like impossible to make 1 farad, and then we are talking about supercapacitors, which are in
Yeah.
500 farads.
Yeah.
That was mind-boggling to me, and it also restored my self-confidence as to, hey, okay,
Yeah.
fine, that guy was an idiot. I wasn't as much.
Yeah.
Um, but then he told me, like SG Tarnekar, Professor SG Tarnekar, he told me stories of where all supercapacitors is used.
Yeah.
It's used to jumpstart electric vehicles,
Yeah.
jumpstart any vehicle actually. Maybe not in production, but it can serve that purpose, jumpstart the car. So the thing about supercapacitors is they can give out extreme amount of or magnitude of current, like 1800 amperes and upwards. That
Mm.
is possible. They don't have any problem doing that.
Mm.
What that helps with, so one of the stories he told me was that if you have a ship docked
Mm.
for too long for maintenance or whatever, so
Mm.
it's whatever rudder, I suppose, or the propeller of that ship,
Mm.
not the rudder but the propeller of the ship, that wouldn't move because it's rusted and whatnot, blah blah blah. So
Yeah.
they actually have a pony motor
Mm.
that kickstarts the engine, so to speak. It moves, uh, and that motor requires like infinite current, so to speak, huge, and supercapacitor is something that can give. So fascinated by that, we also then decided, hey, how about we use supercapacitor and see if we can create a vehicle that and well, we were more dumb than, well, you were like super smart, you took an Activa. We decided to go pure mechanical and electrical engineering way. We were like, okay, let's start by making a bike.
Yeah.
so 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 we made
I will tell you
something that,
more about it. Why I take that decision to take that
okay,
active. I will tell you later. But
okay,
please continue about your story.
okay, I'll conclude mine. So what happened there then was we reached out to some manufacturer of the college projects,
Yeah.
told him what our plan was. We
Yeah.
gave him A as a sketch. We
Mm.
decided B.
Hmm.
He thought C, delivered on D, we presented E. That's what happened. So that thing that finally came out, it was a
Yeah.
seat with three wheels,
Yeah.
one of them connected to a motor. Man, it was a mess, but a fun mess. And instead of powering that motor with supercapacitors,
Yeah.
we just powered it with battery. So our entire project was like, hey, what have you built? What is the point of this if the supercapacitor is outside?
So
So we
why you
changed.
replace
Oh, because the supercapacitor would just die too soon. It wasn't enough to power it like any bit. We would just start and like the capacitor is out.
it? Okay.
So energy density was the problem. It cannot hold. Well, the capacitor we had, it was
Hmm.
a Maxwell capacitor, so it did not have enough capacity to hold enough charge so that it can run the vehicle for longer. It
Yeah.
would just maybe propel it for 10 meters, then the capacitor is out, the demo is over. So we were then like, hey, you know what? Actually, our project is not capacitor powered electric vehicle. Our
Yeah.
project is studying the use of capacitors in electric vehicle, and our conclusion is it cannot be used. So that's it.
So you just
Um,
pivoted it.
so
आप
you just.
आपने पिवोट कर दिया अपने आइडिया को.
Yes, we just, for the sake of our thesis and all of that, we pivoted on. We actually then thought of some more creative ideas because the problem was capacitor was 12 volts, fair.
Hmm.
And as you can see, supercapacitors, well, they come in 2.5, 3, 1.5 volts, that kind.
Yeah.
So then you have to, like the internal assembly of the capacitor bank is that you have things in series. So we were
Yeah.
like, hey, you know, this is taking like 10 minutes to charge, for example. Actually, it would take longer. But how about we take all the internal capacitors, charge them separately. So the
Okay.
charge time is reduced by n. If five
Okay.
of them take, 1 hour to charge, individually on a separate charger, they would take one fifth the time.
Okay.
That was our proposition. And we were like, okay, how about this? If we are using it in EVs,
Hmm.
during the charging cycle, how about we internally connect them through MOSFETs and all of that in parallel so they
Yeah.
charge fast. And once
Yeah.
it's time to power the vehicle, they are in series.
Okay.
So that idea, by the way, later got patented. And I,
Okay.
like, the college submitted it for patent and all of that. I have no idea what they submitted.
Okay.
They just asked us to sign on different papers. We just did. We wanted our thesis and our degree. So we were like, take it, do whatever. But yeah, got a patent on that. That anyways, EV.
So you have patent on that.
Yes, I do. I don't know where that patent exists. I got a
Yeah.
email in 2015 from one of my friends saying, "Hey, did you try Google searching your own name? This shows up," and then we laughed out saying, "What is this?" But yeah, that's that.
Yeah.
So,
Interesting. From class 11th to patent.
oh yeah, and well, I also have. If you search now, so I also have a patent from Google this time around, also
Okay.
on supercapacitors.
Okay. So it is also on super.
Yes. So I don't know. I'm just fascinated by this so much so that it has served me really well. Yeah.
Yeah.
So
So I'm just curious. What is, अभी आपके डेस्क पे वो कर क्या रहे हैं मतलब you are making something or
right. Okay. So my plan is, and by the way, maybe that is where the nudge to go back to the two-wheeler project comes from,
yeah.
which is so these cannot power an EV. They cannot replace the batteries. What
Yeah.
they can do though is they can help capture the regenerated energy. So EVs,
Hmm.
they have a motor on them.
Hmm.
Uh, so when you try and brake the EV, there are two
Hmm.
ways. One is you use the brake pad to slow down the wheel. The
Another
second way,
region.
regenerative. So this serves as an excellent way of capturing the regenerated energy. Why, if you ask? It's
Hmm.
because you can just take this as is, and well, do not try this at home for anyone. The summary is that internal resistance of this thing is very tiny. which
Yeah.
then means whatever current is being fed into this, the I squared R, the heating losses are very tiny, and so it doesn't explode, but
Yeah.
it captures all the energy. So,
Yeah.
what I wanted to do with this, to answer your question, is to create a small setup to demonstrate how regenerative braking works.
Okay.
That's where, yes,
Now I
that's where
got.
this is headed.
So you're
Yes, long
basically making
answer,
time.
prototype, yes. And hopefully, I only have one at the desk right now, but if we have two of these, then I
Yeah.
precisely want to implement my college project, which is
Okay.
have two of these when regenerating, regenerate in parallel,
Yeah.
when powering back the motor, power in series. And if I achieve that, well, then there is some sense in that patent.
Yeah. Why not?
Go
So
back and now tell me about the Activa.
yeah. So जब वो दोनों लोग किक आउट हो गए थे, सो
Uh-huh.
फिर मुझे भी लगा कि बेसिकली आई एम टेकिंग दिस प्रोजेक्ट एंड आई डोंट नो हाउ ईवी वर्क्स। हमने जो डीसी टू डीसी चॉपर पढ़ा है वो सारा सब कुछ पढ़ा
Hmm,
है, बट
hmm,
वी डोंट नो प्रैक्टिकल थिंग्स अबाउट इट।
hmm,
So we need to understand how practical things are working.
hmm,
So I read a bunch of material on the same,
hmm.
how these are making and all those.
Right.
So at that time we have internship season. So I got an internship in Revolt Motors. So they are making
Nice.
okay. So they are making electric scooties.
Right.
So there, I guess around they have around वहाँ पे लगभग 20 से 25 लोग थे जो सिर्फ डिजाइन करते थे चीजें।
Hmm.
ओके। सो एंड तो वहाँ से मुझे एक चीज तो समझ में आ गई कि डिजाइन अपने दम पे तो नहीं हो पाएगा, बिकॉज
Okay.
मैकेनिकल स्टफ इज
Man, it's
so
next level
so
stuff.
complex,
Yeah.
so complex, and
Yeah.
if you put अगर उसमें कुछ भी एंगल का एरर होता है तो वो पूरा बेकार हो
Things
सकता
won't
है।
fit. Yes. Yes.
तो उसमें बहुत सारी चीज़ें होती हैं, शीट मेटल को कैसे बेंड करना है, क्या कैसे करना है। सो आई 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 थॉट कि ये तो नहीं हो पाएगा क्योंकि ये अलग सेट ऑफ कॉम्प्लेक्सिटी है।
Right.
क्योंकि इलेक्ट्रॉनिक्स पॉइंट ऑफ व्यू से इलेक्ट्रॉनिक्स अपने आप में चैलेंजिंग है कि हाउ यू कैन मेक मेक दैट मेक दैट स्कूटी रन। तो इसीलिए वी डिसाइडेड कि यार वो तो नहीं होगा, सो लेट्स लेट्स get some Activa, get
Hmm.
some old Activa from somewhere।
Hmm.
तो इसीलिए वो हमने डिसाइड किया कि वहाँ पे मैंने जो कॉम्प्लेक्सिटीज देखी कि ऐसे ये लोग 15-20
Hmm.
लोग कर रहे हैं और फिर इसमें फिर भी इसमें
It's not going.
या उनके भी बहुत एरर्स आते थे कि
Right.
ये यहाँ से बहुत ज़्यादा है, ये यहाँ से बहुत कम
Hmm.
है, एंड
Hmm.
सो आई थॉट आई गिव अप ऑन दैट, सो आई जस्ट फोकस ऑन द
Right.
इलेक्ट्रॉनिक्स पार्ट।
And this then brings me to this fact that, and nothing wrong with dreaming things. One should definitely dream big. I'm a huge supporter and believer of that. But I suppose back in the college days, it's like, hey, the world doesn't know how to do it,
या
but I have arrived. So let me
या
straight up, design this awesome
या
bike or a car.
या
And then we discovered that, okay, there are too many moving parts.
या
Uh, and I suppose that's what happened with you and even with us, A, B, C, D, that whole thing.
या So that's so true. The thing is, another story is जब मतलब मुझे भी डर लग रहा था, आई एम टेकिंग दिस एंड आई डोंट नो मच अबाउट इट। सो
Hmm.
वो एक पूरा अननोन टेरिटरी है जो तुम्हें
Yes.
नहीं पता है।
Yes.
सो एट दैट टाइम आई एम गोइंग होम।
Hmm.
तो दिवाली की छुट्टी थी, उस टाइम भी दिवाली थी, अभी भी है। तो तो दिवाली की छुट्टी थी, तो मैं घर जा रहा था एंड आई एम मैं बस में बैठने जा रहा था। सो आई आई सॉ देयर इज सम रिक्शा जिसमें
Hmm.
उन लोगों ने ये सेम सेटअप किया हुआ है। ये बैटरी वाला बैटरी
हाँ.
जो नॉर्मल रिक्शा है उसमें उन लोगों ने बैटरी लगा दी है और मोटर्स
Motor.
वगैरह लगा रखी है। सो उसको
Hmm.
देख के मुझे मतलब ऐसे बहुत ज्यादा ऐसे लगा कि यार जब ये लोग कर सकते हैं, सो व्हाई नॉट अस।
Right. Right.
जब तो मैंने उनसे उसकी पूरी मतलब समझा कि भाई ये कहाँ बनता है, कैसे बनाते हो, कितने पैसे लगते हैं। तो आई गॉट ऑल द डिटेल्स अबाउट दैट। एंड जब मैं फिर घर से लौटा वहाँ पे, तो सबसे पहले मैं वहाँ गया कि भाई
Hmm.
ये कहाँ से क्या कर रहे हो, कैसे करते हो। तो
Hmm.
फिर इवेंचुअली फिर जो हमें पार्ट्स नहीं मिल रहे थे, जो मोटर कंट्रोलर था, तो फिर हम उसी वहीं से लेके आए थे
Ah,
शॉप। सो
nice.
आफ्टर कंप्लीटिंग दैट प्रोजेक्ट, मुझे एक चीज समझ में आई। सो पीपल आर मेकिंग स्टफ कॉम्प्लेक्स, चीजें उतनी
That is so
कॉम्प्लेक्स नहीं
true.
होती हैं।
That is so true. And over engineering, or I think you can correct me if I get this wrong. But the
या
thing is, people will try to make something complex because the easy thing or simple thing looks too easy, and hey, that's not engineering, right?
आई थिंक
Unless I have made something that looks and feels complex to me, yeah,
या
I have not achieved something. But most engineering stuff is simple. Do the simplest stuff.
या आई थिंक another point of view is, if you are making it complex, then you are not understanding it well enough.
True. Also true. Yes. Yes.
So these things are not that complex if you
Hmm.
go from basics. Like, this is inverter, what inverter is doing, converting
Right.
DC to
Right.
AC,
Right.
and what this device is doing. So
That is so true.
when your basics are clear, you can approach it from any angle.
The first principles
Yeah,
approach. I'm going to encourage all of us, the viewers, you, me.
yeah,
If you look at the way Elon Musk does things,
yeah,
take his rockets for example, right? The landing rockets.
yeah,
I mean, this is an oversimplification. Obviously, there are too many complex things going on there at the engineering level, material science specifically. But landing a rocket back to its place, just imagine the kind of technology required. It's something called thrust vector control. So you have two motors, one to push the nozzle in the x direction, other one in the y.
mhm,
And then what you do is, while the rocket is coming down, you just control in which direction does the thrust go. Uh, Essentially a vertical or inverted pendulum problem, but
yeah,
floating. That is the kernel of the idea. That is the central idea, and
yeah,
everything around it, the materials, the
yeah,
occasional, the rockets on this tiny rockets on the side that correct, let's say, or the fins and all of that in that particular rocket, the
yeah,
self-landing ones, they are just assisting the main key idea, thrust
yeah,
vector control. And
mhm,
second, if you now look at Tesla as a vehicle or any EV, even the two wheelers that we tried,
yeah,
motor, battery, by the way, outside of mechanics, motor, battery, power electronics, done, right?
yeah. And some software part.
Software, yes, but I'm including software in the power electronics part. But if you're talking about like the dashboard and stuff like that, then definitely yes, right? More software. But the EVs are way, way, way less complex than
Yeah,
IC engine.
या डेफिनेटली। उसमें तो मतलब बहुत ये कॉम्प्लेक्सिटीज मुझे तो पता भी नहीं थी। सो आई आई वॉच लॉट ऑफ यूट्यूब फॉर दिस। आई आल्सो वॉच, देयर इज अ चैनल लर्न इंजीनियरिंग, लेसिक्स।
Go
या
ahead. Yes, I think I've come across that.
सेवन मैथ्यू करके
Hmm.
एक, आई गेस एक बंदा
Hmm.
है। सो उन्होंने मतलब इतना सिंप्लीफाइड बना रखा है
Hmm.
कि हाउ ईवीज आर एक्चुअली वर्किंग, व्हाट इज इन्वर्टर इज डूइंग।
These are animation videos, right?
Yes, 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 yes. The
Yes.
animation video explain every engineering in
Ha.
animations, like
Right.
what is happening, how gears are turning, what is
Hmm.
automatic
Hmm.
transmission,
Hmm. Hmm.
all
Hmm.
those. तो उसके कंपैरेटिवली, हाँ, मतलब ईवीज आर मच सिंप्लीफाइड कंपेयर।
Yeah,
उसमें तो
compared to IC engine. Yeah.
हर एक टूथ का वो अलग कैलकुलेशन लगाते हैं कि ये गियर में ये
It
ऐसे होगा।
is crazy. Man, you look at an EV now, and
या
then it's like, wait, the IC engine and the diesel engine looks like horse carriages. They are
या
well slow. They don't have torque. None of that to achieve. Well, that reminds me, by the way, just today this is again just to speak in favor of EVs.
या
The fastest car in the world is
Yeah.
now, well, BYD's Yuwang or something,
Okay.
and that reached the top speed of 496 kilometers an hour.
Interesting.
Absolute crazy. And
Yeah.
it produces, I think, twice the horsepower of the world record, the previous world record holding car, which is Bugatti Chiron. Bugatti
Okay.
Chiron had 295 at 300. Sorry,
Bugattis,
Chiron. I think I can't spell it.
or Koenigsegg. I
Koenigsegg.
thought it is. I thought it is
Ah,
Koenig.
okay, okay, fair. It could be
Maybe I'm wrong.
Koenigsegg. No, no, no. I need to correct myself. Which is the
Yeah.
fastest production car.
Yeah.
Bugatti Chiron had that record. I don't know if
Okay.
the Koenigsegg was like a production car or just like a. I have no idea on
Consider.
that.
Okay.
It could be that. But anyways,
Yeah.
496 kilometers an hour. If we had like a straight road from here to Hyderabad, from Bangalore to Hyderabad, that would be like 1 hour something minutes. Crazy, crazy man, crazy. Wow, that's that. Cool. Okay, I think we are over 1 hour 15 minutes. I know
Yeah.
that you're yet to have dinner, and well, it's
Yeah.
10:30 at night. So I think we should wrap up for today, and we can
Yeah.
meet again to talk
Yeah.
more
Yeah. Sure.
PCB design stuff. Maybe
Yeah.
my request would be, now that you have been through that journey and you are somewhere like experienced professional in that department now, maybe you are the right one to guide us through on how to read schematics, how to
Okay.
read what part is what are different layers. Maybe just walk us through the KiCad software at some
Yeah. Yeah.
time.
Yeah. Why not?
Perfect,
Yeah.
perfect,
In the next session, we can do that. How to
perfect.
read schematic and how we can make our custom designs.
Let's do that. Yes.
Okay.
Perfect. So, thank
Yeah.
you for joining in on the last moment.
Yeah.
And yeah, if the audience has enjoyed this, then please do
Yeah.
visit. Well, first off, show love to Hardik, and then also do visit his channel and the playlist. All
Thank
right.
you, guys.
Perfect.
Okay.
So with this, let's stop the recording.
Okay.